Welcome to the Explainer. Okay, so for a lot of us, spring means one thing: war against pollen. But what if I told you that this stuff we're all sneezing at is being turned into a seriously revolutionary new technology?
Yeah, when you hear pollen, you probably think allergies, right? Sneezing, itchy eyes, the usual misery. But what if we could just flip the script on this microscopic dust? What if it's not the enemy at all, but the key to creating brand new medicines or even making our forests healthier?
All right, so here's how we're going to break this down. First, we'll see how pollen goes from being just an allergen to a valuable asset. Then, we'll get into how it becomes this tiny programmable factory. After that, we'll look at the two big applications: new medicines for us and a serious boost for our forests. And finally, we'll peek into the future of engineered pollen. Let's get into it. Okay, first up, from allergen to asset. To really get this, we've got to look past all the stuff on the outside of pollen that makes us sneeze. Because once you strip all that away, you find this incredibly tough, super versatile structure inside. And that is what makes this whole new science possible.
So the secret ingredient here is a material called sporopollenin. Now, this stuff is basically one of nature's most durable materials. It's this super tough, resilient outer shell of the pollen grain. Think of it like a natural armor. And its structure is what makes it so cool. It's incredibly strong, but it's also got these tiny nanoscale channels running through it, which, as you'll see, makes it perfect for engineering.
Okay, so what can you do with this stuff? Well, scientists have figured out two really cool ways to process it. If you treat it with acid, you get these hollow, super sturdy shells. They call them sporopollenin exine capsules, or SECs for short. These are perfect for loading things up like a tiny cargo container. But if you use an alkaline solution instead, you get something totally different: these soft sponge-like things called microgels. You can even print with them. So you've got these two forms from the same starting material, each with its own amazing and useful properties.
So we have these shells and sponges, but how do they actually work? This is where we get to the absolute core of this research, turning these pollen structures into what they call pollen microbiome microbioreactors. A bit of a mouthful, I know, but the idea is brilliant.
So, this concept, PMB, basically reframes pollen. It's not just a passive little particle anymore. Think of it like a microscopic kitchen, a perfectly designed kitchen that helps microbes cook up powerful new molecules. You see, the pollen shell itself, its unique structure and chemistry, actually guides what the microbes do inside. It pushes them to create brand new compounds that you just wouldn't see them make anywhere else.
And you know what's wild? The process itself is surprisingly straightforward. Step 1, you get your pollen. Step 2, you give it a wash to get rid of the allergens, and that creates either the hollow shells or the soft gels. Then, step 3, you add your little workers. These could be helpful microbes or enzymes, and you give them some raw ingredients. And that's it. The pollen structure does the rest, creating this unique little world where these microbes can produce amazing, brand new bioactive molecules.
All right, so now we know how it works, but what can we do with it? Well, this technology has two pretty revolutionary applications. Let's start with the first one: creating new compounds to improve our own health.
So inside these tiny pollen bioreactors, you can get microbes to make a whole new class of beneficial stuff. We're talking about things like new hybrid molecules that could have some serious anti-inflammatory power, or flavonoids that are more stable and easier for our bodies to absorb. And get this, you can even create specific prebiotics designed to feed the good bacteria already living in our gut. It's incredibly targeted.
And this really shows you how high they're aiming. The researchers are targeting an anti-inflammatory potency of 10 micromolars, or even less. Now, to put that into perspective for you, that's a level of effectiveness that's right up there with some actual pharmaceuticals. And it's all being generated inside a tiny, hollowed-out piece of pollen. Just wow.
Okay, so that's the human health side. But the other side of this coin is, I think, just as exciting. It's about using the exact same principles, not for our bodies, but to help our forests, to help them grow stronger and be more resilient. So, the idea here is you load up these little pollen bioreactors, the PMMBs, with microbes that are good for plants. Then you can just apply them as a coating on a seed or as a dip for the roots before planting. And what happens is, they give the seedling this massive head start in life. The compounds the microbes make can actually prime the plant's immune system, tell its hormones to grow better roots, help it suck up more nutrients and water, and even suppress diseases right from the get-go.
And just like with the health track, the goals here are seriously ambitious. They're not just hoping for a small improvement, The pilot programs are aiming for some really significant measurable results. We're talking a 20% jump in how many seeds sprout, a 30% drop in disease, and a 10% better chance of survival when things get tough, like during a drought. That's a huge deal for reforestation.
So where does all this go from here? This is what I love about this research. It doesn't just stop with a cool idea. It actually lays out a super clear path from what they're doing in the lab today to a future vision that is, well, it's pretty mind-bending.
For the human health stuff, there's a really practical 2-year roadmap. It starts simple. In the first 6 months, build and test the basic materials. Then, over the next 6 months, figure out how to scale up production and focus on the compounds that show the most promise. And from there, the goal is to have actual prototypes, like for nutraceutical, ready for small human safety tests in just 1 to 2 years. That's moving fast.
But the ultimate vision, the long-term dream here, is something straight out of sci-fi. The goal is to actually engineer plants so they produce pollen that is already loaded with these special enzymes. So the flower itself would be producing these perfect tiny bioreactors naturally. No processing needed. The whole system would be self-contained. It's a pretty wild thought.
You know, seeing this incredible journey of pollen, from something that just makes us sneeze into a high-tech tool for medicine and for our planet, it's just a powerful reminder, isn't it? It really makes you stop and wonder, what other everyday things, what other common natural materials are hiding these kinds of incredible world-changing secrets, just waiting for us to find them?